All right. I don't have the paper. Somebody put the extras on my desk, I think. Number 12. Joel, okay, you have to understand, this is what I tell calculus all the time. The hardest part of word problems is figuring out what goes where, like what exactly they're talking about. Because you know how to do the problem. You just got to figure out. So for these, it's the picture. Draw a picture. It'll really help you. Okay, so Joel is ziplining, and so let's think about the way a zipline does. He's ziplining, it's going down. It's got to be going down, otherwise he's not ziplining, right? You don't zipline straight across, you zipline down. Okay. Joel is ziplining in the mountains. If the vertical distance from his platform, and this is vertical's up and down. So here's Joel's platform. Vertical distance down to the next platform, so down. So that means he's coming down to this other one. So this distance down is, I lost my place, 304 yards. And then it says the angle of depression. All right, so depression, remember I'm going from his eyeballs. In this case, I drew it from his hand. Is 21 degrees, 43 minutes, and 30 seconds. That means that this is 304. I am looking for the hypotenuse this time. I would make this, I would do 21 plus 43 over 60 plus 30 over 21.73. I've got the opposite. I need the hypotenuse. This is a what kind of problem? Sine. The sine of 21.73 equals opposite over, this is what I need to find, so I'm going to put a variable here, over hypotenuse.
I did cosine as well.
Cosine wouldn't work because you're not given the horizontal distance, you're given the vertical distance.
But I didn't draw my triangle. Move it this way. That's how I. Like if you're standing at the person, you're at the person. I went down and then right, and then diagonal with like that.
Then yes.
I did.
But that would make your theta be here. Because this is not an angle of depression. Angle of depression has to shoot out from your eyes and look down. So that's why. So you can flip your triangle.
Well, then what was it thing in our notes?
That's still not your angle of depression. It has to go from the person straight across, that's one side, and then where they look down, that makes the angle. No, up top. Yes.
Okay, so depression's always in the bottom corner. Right?
Well, it's always
I see.
It's always at the top corner. If you flip it, it'll be at the bottom other side, yes. I'm not sure why y'all keep drawing your triangles like that, to be honest.
It just makes sense. The way you're doing it down. You're looking down. Yeah,
Yeah. Okay, so the angle of depression would be where your line of sight hits the ground and meets the ground.
Yeah. Mine is meeting the ground right there. How 304 wasn't the hypotenuse.
How what?
304 wasn't the hypotenuse. Yeah, I put 304 as the hypotenuse. 41 degrees.
Because that's the zip line. The hypotenuse is the zip line. I drew that before I did anything else. If you drew your triangle the other way, if this is Joel and he's ziplining this way, then here's my angle of depression. This is 304. It's still a sine problem. Yeah.
I thought you were looking for the base of the triangle, like.
And most of the time you're wanting to know if I'm this far, how tall, or if it's this tall, how far am I? Most of the time it's what you look. It's odd to look for the hypotenuse. I got you. I had to think about this one a while whenever I read it because but think about what they're doing is if you think about like a zip line, here's another place where somebody else could get on another zip line and troop on down some more. So you have these different platforms that. And then, yeah. Look at what you have and what you need. So if I'm here, I have the opposite. I need the hypotenuse. So which trig function deals with opposite and hypotenuse? And there's only one. Sine. Sine is opposite over hypotenuse.
Vertical distance, we do that with vertical distance. And it's just finding the angle of depression. I don't know how to put it. Figure out what goes with it. But I knew I had the vertical part of my triangle as 3 and 4. It was just the angle.
That's why I said it's easiest if you always remember it straight out from the eyes, and then if you look up, it's that line from the eyes up, that's your elevation, and if it's down, it's your line down, so that's your depression. Theta is always at your person. So if he's looking up, this is theta. That's your angle of elevation. You draw the way he's looking. He's looking up, and then you draw a horizontal line from his face. When he's going down, he's looking down, and you still horizontal line from his face. That's always theta. Where's eyes? Yep. All right, 13, a string connecting the corner of a square canopy to a point on the ground. Okay, so think the cup, it's fixing to be the cup, right? Yeah. Oh, I don't know. I didn't finish. It was, what'd y'all get when you put it on the calculator? So x times sine equals 304. So on your calculator, put 304 divided by sine 21.73. 821. That's tomorrow. A string is connecting the corner of a square canopy. Canopy, think tent, like at the cup canopy. That's what they're talking about. Like, can't really. It's like a tent.
I thought canopy, like the little thing, like the thing you lay in.
A hammock?
Yes.
Okay, so it's connected the corner of a square canopy to a point, and I know you've seen them. They're staked up on the ground, like a tent, right? 15 feet from the base of the canopy. Here's the canopy. Here's the base. So this is 15 feet. The angle of elevation from the point on the ground, so from here to the top corner of the canopy, so to here, is 37 degrees. Find the length of the string. The hypotenuse is the string.
Oh my God, I messed up. Which one is this? But I also just made it a triangle and started writing stuff.
This is 13. I have the adjacent. I need the hypotenuse, so I'm going to use cosine. Adjacent over hypotenuse. You get what? Adjacent and hypotenuse is what we had. Adjacent and we need hypotenuse. But that's what we need. That's what we're trying to find. So you look at what you have and what you want. Right. All right, hot air balloon. Last one. This one was the hardest. Erica. Spots. A red balloon due east. Okay. At an angle of elevation. Now here's where you have to understand angle of elevation. She's looking up. Straight across, this is theta. This is 36 degrees. 100%. She turns due west and sees a blue balloon at an altitude, angle of elevation 51 degrees. If the altitude of the red balloon, now here's where you have to be careful. The altitude of the red, which means she's standing on the ground, yes? From the balloon all the way to the ground.
I thought that was just information that threw me off.
The altitude of the blue balloon is 461 feet.
I thought she was the short leg. I literally did not know how to do this. I thought she was the short leg, so I had two triangles.
Erica is 1.6 meters tall. Find the distance between the two balloons. So I'm looking for this. And that is just the sum of two different legs. So I need this one and this one. Or this and this added together. Just a second. All right, I'm going to subtract 1.6 from these altitudes just because I'm pulling these triangles out. So what's 461 minus 1.6? 459.4. And then over here, 296 minus 1.6, 294.4. Now, for both of these triangles, find this distance. What? No. Subtract them from what? But then you don't. You can only do this with right triangles. They're only right triangles because of this. So no.
I literally wrote a question mark on that one.
All right, both of these are going to be sine, right? Sine 51 equals, nope, they're tangent, just kidding. Tan 51 equals opposite over, nobody got it, adjacent. Tangent of 36 equals opposite over, I'll call this one y. I think y'all can handle that from here and you add x and y together. And then you're going to be really mad. I'm going to make you write first, then I'm going to give you a blank one. You will probably want several copies of the blank one to prepare for your test because I'm going to give you one exactly like what your quiz/test will look like. And it'll be a memorization thing. But before we actually do that, I want you to, I feel like if you understand how and why the unit circle is what it is, it'll help you. Some people just, it's in one ear, out the other. Just tell me what the values are. Let me memorize them, and I'll memorize them. Others of us like to know why. I'm a why person. It helps me understand. I know you are. I could just give you a laminated copy of the unit circle and say you'll have a test on it Friday, and you would just go home and memorize it and would have no. All right. The unit circle sits on the xy plane. Okay. And the radius of the unit circle, here's why it's called the unit circle, because the radius is 1. It's always 1. So it goes up 1, down 1, over 1. So draw your circle as best you can. Mine never turns out good. It's okay. Now, obviously, these points on the end here are very easy for us to determine. This is just 1, 0, 0, 1. It needs to be, we're going to, each coordinate, what am I trying to say? Each quadrant, great day. Each quadrant will have 3 points that we're going to derive on it. Whole entire unit circle. The whole stinking thing. All right. Here's what we're going to do. We're going to find the coordinates at certain angle measures. In other words, if I could, remember we talked about those standard position angles and what theta would be? Let's say that I let theta be 30 degrees. That's okay. And I think I'm just going to draw so that you know what to put on yours. I think I'll just put all 3 on here so that you see. And I think I'll write it up here. Well, yes, you need the degrees.
So the whole thing from the black down to 45 and the green.
Yes. I'm talking about thetas that are sitting, these angles are sitting in standard position. So one side of the angle is the x-axis, the other goes up, and this is what they measure. So 30, 45, and then the last one, I'm just stalling because I need a different color. Oh, that's cool. No, that looks just like the other one. I feel like that I think that's what that is. Okay, perfect. See, that looks just like the blue. I'm gonna use this yellow. This one is 60 degrees. All the way down. All right, so we've got 30, 45, and 60. If I gave this one an angle measure, what would it be? 90, because this is obviously 90 degrees here. Okay, is everybody with me on what's going on? Now, I want you to think about something for just a minute. Let's look at just this point right here first. To know the coordinates of that point, I would need to know at how far over it goes, and that's my x coordinate, right? And then how far up it goes, and that would be my y coordinate. Do you agree? Do you see a right triangle in this? Yes. In fact, I see a special right triangle. What special right triangle do you see in this? 30, 60, 90. I've got a 30, 60, 90, and I'm going to come over here, and I'm going to pull this triangle out so you can see it. 30. We said that's got to be 60 because it's a 30, 60, 90, right? What else do I know? I have another piece of information here. It's 1. Why is it 1? The radius is 1. No matter where I go from the center of the circle to any point on the circle, it's 1. So the hypotenuse of this is 1. Now could you find those missing side lengths? Because the missing side lengths are going to be my coordinates here, right? So this would be my x coordinate. This would be my y coordinate. Do you agree? Okay. So 30, 60, 90, always get back to the short leg. How do I get back to the short leg? From the hypotenuse, you divide by what? 2 to get to the short leg, right? So that means the short leg, which one's the short leg, x or y? Y. That means y is 1/2. Now, what about getting from the short leg to the long leg? Square root of 3 times the short leg. So this would be square root of 3 over 2. And all of a sudden, I have my coordinates for this point. Square root of 3 over 2, 1/2. One thing we didn't do, I forgot, I should have done this initially. This is 30 degrees. It's also how many radians? Pi over 6. I was like, dang, that was quick. Pi over 6. You have to know, so for on your quiz, you'll have to know degrees and radians and coordinates.
Wait, do we have to find the coordinates every time? Or do we just memorize?
I'm going to show you. Once you get either one. All right, so a 30, 60, 90 triangle. You always make your way back to the short leg. The short leg is across from the smallest angle. Whatever this value is, you double it for the hypotenuse, you multiply it by the square root of 3 for the long leg. I think we went over this when you weren't here. So all we're doing on this one is we're going backwards. We're going from here to here and then using that to get to this. Because the horizontal distance here gives me my x coordinate and my vertical distance here gives me my y coordinate. It has to do with everything. Huh? If you start with the short leg, yes, but we didn't start with the short leg. We started with the hypotenuse, so we had to go backwards. Ideally, you would start with the short leg, but we didn't have it, so we had to get there. No, I'll help you with it. I'll help you with it. All right, let's look at the second triangle. Here's my second triangle. 45, 45, 90. What would I be here in radians? Pi over 4. How'd you know? Pi over 4. So 45 degrees in radians, you would multiply by pi over 180. All right. I have this 45, 45, 90 triangle. And that just means that two legs are the same. Again, I have the hypotenuse. How do I go backwards on it? Square root of 2. Short leg times square root of 2. But I'm going backwards. So I'm going to divide by the square root of 2. What? Yeah. Because you always make it back to the short leg. Whatever you have, get to the short leg and then use the short leg to write the long leg. So short leg times square root of 3. Yes, on the 30, 60, 90. I went backwards. Stella went back and asked a question about that one. Are y'all okay? No? You with me? Okay. I'll show you. All right, let's look at this last one. Why is what the same? Yes. Good job. What?
You're looking at the wrong one. You're looking at angle 60.
Okay. And I'll get y'all some laminated copies once we get past the memorization part so you can reference them. So you don't have to keep looking at your sloppy ones. I'll make you learn it first. All right. Here's my last triangle. 60 degrees. Give it to me in radians. Close. No. Pi over 3. All right, so it is. That's why it's hard to memorize the patterns. But if you remember how to do things, you can come up with it on your own. All right. I've got another 30, 60, 90 triangle, but this time I'm starting with a different leg. Right? This time I'm starting with, or this time my long leg is over here. So my values are the same, but they've switched places. Do you see that? So now this one is 1/2, and this one is square root of 3 over 2. So I have 1/2. Yes. It's the same triangle, just turned the other way.
Are the other terms like the exact same thing? If you know one, you know.
If you know one, you know it all.
So you know what
Okay.
What? Yeah. Yes. No, we're missing one. We got to get this top here, and then I got to tell you why this is important and what we're going to do with it. 90 degrees. 90 degrees. Okay, except for, well, 90 degrees, right? What's the radian equivalent there? Pi over 2, or 1/2 of pi. So this is pi over 2. We've already got the coordinates. There's no sense in doing that again, right? Because the radius is 1. All right. Let's click through and finish, and then I will tell you why. This actually, Take out your calculator. Put it in, make sure it's in degrees first. And I want you to hit sine 30. Sine 30. Now do cosine 30. But in your calculator, put square root of 3 over 2.
It equals the same thing. Cosine of 30?
Change over to radians. Hit mode. Sine pi over 6.
0.5.
Cosine of 30. Pi over 6.
Oh my gosh.
Who's made the connection yet?
I don't know what I'm talking about. It's because I can use the unit circle instead of using sine. I can just know what it is.
These give exact values of our trig functions.
That's
Okay.
crazy.
So, and then radians or degrees. The x value, cosine of theta, is your x value at that particular theta. So if it's cosine of 60, I'd go to 60 degrees. It's 1/2. The sine of theta is the y value at that particular value. So if I said, what's the sine of 45 degrees? What would you tell me? Square root of 2 over 2. I'm glad you asked. Okay, your x values are your cosine values. Each of these points, golly geez Louise, each of these points on the unit circle is cosine sine at that particular theta, whether you're in degrees or radians. Yes. Okay, tangent's a little confusing, okay? Tangent, and we're going to go through and find the tangent values here, and then we're going to fill out the rest of the circle. Tangent, okay. All right, when we find a normal tangent, let's think about our circles. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And this is opposite over adjacent. So if I told you that tangent is sine divided by cosine, would that make sense to you? If I did opposite over hypotenuse divided by adjacent over hypotenuse, multiply by the flip, look what I'm left with, right? So here's what I'm going to do for all. You can find tangent by using sine and cosine. Here, if you not, that's okay if you don't understand that, memorize this. Tangent is sine over cosine. If you're a why or a how person, here it is. If you're not, here you are. Okay? All right. So, back to the unit circle. If it's sine over cosine, right? Let's start at this easy one. Then here, the tangent is 0 divided by 1 is 0. Here, the tangent is, and I might have to come off to the side to do this, 1/2. Let's go tan 30 degrees. 1/2 divided by the square root of 3 over 2. No calculator, exact only. 1 over the square root of 3. Take the y value and divide by the x value. That's what you're doing. Yeah, but just wait. There's your very, very important pieces there. Y'all find the tangent right now of 45 degrees and pi over 3. Tell me what you get. Yes.
I don't understand. I think we'll need a whole day for this.
All right. Listen, remember, I'm showing you how to derive it. I am okay with you just memorizing it if you'd rather. If you'd rather just look and go, okay, I remember these. I know this is square root 3 over 3. And you just want to memorize it, that's absolutely fine. Remember, what the hardest part is getting this first quadrant done. Once we get this first quadrant done, the rest is downhill from here.
Downhill. Okay.
No, that's hard. Uphill's hard.
Uphill's easy.
Downhill's, whoo.
No, downhill, that means they go back.
Like my life is going downhill. You know what I mean? Said after this is down here, down here.
It's not like you're striking uphill, it's like you're going up instead of like falling.
It's gonna be good, y'all. It's gonna be good after this. All right, look at what's boxed in black there. The tangent is y over x. You take the coordinates, that's right, which is
I understand now.
how about the next one? It's just one. If you divide anything by itself, right. All right, so look, at 60 degrees, I'm going to come up here now. At 60 degrees, I'm at 1/2 square root of 3 over 2. So if I do y divided by x, y divided by x. I can't divide a fraction by a fraction. I multiply by the flip instead. Square root of 3 over 2 times 2. What's the tangent value at 60 degrees? It is. How about it? What about 90? Error. Why is it an error? What are you dividing by? Divide by 0. You can't divide by 0. So here, it's undefined. Okay. And let me just take just a second. Remember when we learned sine, cosine, and tangent graphs as the parent graphs? The tangent graph, every pi over 2 has an asymptote.
Yes,
It cannot exist at pi over 2. And that's 90 degrees. See how it's all coming together? It's beautiful. The more you work with it, the more parallels you will start to see in so many things. Okay? Yes. Yeah. Huh? That's from back in the beginning. All right. Now, I have my first quadrant laid out. Okay? It's all good from here. Now, here's the nice thing about the unit circle. Everything is symmetrical, okay? Everything goes exact. The hardest thing about, in my opinion, is finding the radian values. because there's not as much of a pattern to that. Some kids have come up, and I'll show you a couple videos maybe tomorrow of some memorization tricks if you're just a memorizer. There's not a rap song, but there's some ways that like, see how everything's over 2 and it goes 1, 2, 3, 1, 2, 3 kind of thing. There's some little tricks that you can remember. Everything's over 2. And if you start here, it goes 1, 2, 3, 1, 2, 3. And everything's really a square root, but the square root of 1 is 1. Yeah. Do not come up with something that leads you astray, though. Don't do something wrong and then you know what I'm saying? Like, don't.
There's a unit
All right.
song.
Okay, let's finish the circle so that you can do what we need to do. By the way, on your calculator, real quick, just double check our work. Do the tangent of 45 degrees and make it pi over 4 if you're in radians. I don't remember what we last did. 1. Look at our nice, beautiful unit circle.
Wait, we're so many in radians now?
If you put pi over 4 radians, if you put 90, then, 45, then degrees. No. That's a non-calculator. And then we'll even do a quiz that's timed. Not the first one.
But I just need to write exactly.
We'll start doing some Kahoots where we'll get really fast with the unit circle values. Like you should get so used to it that I go, Stella, cosine of pi over 4. Boom, square root 2 over 2. All right, let's finish up. We got 3 points on each quadrant, okay? And they're each equidistant, or I shouldn't say equidistant, but I'll show you how I come up with them. All right, if this goes from 60 to 90, so that means there's a 30-degree difference, right? So this would be 120. 90 plus 30, so 120. I think I'll write it up here, 120 degrees. In radians,
It's 2 pi over 3.
it's 2 pi over 3. Thank you.
I think that's good. But we can just take the.
Now we just take the coordinates from over here. Yes, yes.
Wait, on this. Yeah, I want to put my radians in a radian.
You'll do both.
Oh.
All right. Look at what happens. Here's what you have to notice. On this side, all y's are positive, all x's are negative. Yes, in this quadrant. So I'm going to take these same coordinates and I'm just going to make the x's negative. And I'm going to keep the y's the same. And my tangent values, remember if I'm y divided by x and one of them is negative and the other stays positive, then here all my tangent values should be negative. So they're going to be the same, they're just going to be negative. So in here, in this quadrant, and this might help you. Sorry, I'll come right back. Sine is positive, cosine is positive, tangent is positive.
And if they're both negative,
Sine is sine is positive, cosine is negative, which makes tangent negative. This quadrant where everybody is negative, tangent is positive because a negative divided by a negative is. You are eating on this one, Zoe. On this one, sine is negative, cosine is positive, which means tangent has to be negative. So if that helps you some.
I don't know what this is.
Sine is your y, cosine is your x, and tangent is when you divide the two. Here's how I remember it. C comes before S, X comes before Y. Cosine, sine, X, Y. X comes before, you see what I'm saying? They're in alphabetical order. Both of them are in alphabetical order.
You do that trick with like so many things.
Yeah. I have to do little things because my brain is not what it used to be. Saying. All right, let's go another click. How many degrees are between these two? 15. So if I was at 120 and I go another 15, 135. Give it to me in radians. There you go. 3 pi over 4. Same coordinates. I should have color coded it so you would see which one goes with which. This one was supposed to be yellow. This one's black.
It's 135 degrees, you said?
Yes. And again, the same coordinates, but the x is negative, the y is positive. Tangent value here. Negative square root of 3. Negative 1. Another 15 clicks. 150.
15 clicks.
5 pi over 6. Clicks.
Yeah.
5 pi over 6.
I did wait, so are the radians the same or no?
No, the radians are changing. Just like the degrees.
Wait, okay, wait. There's more triangles that we done for today.
Yeah.
The last one is negative 1, 0.
Tangent here, don't forget tangent.
Yeah, I was waiting.
Now look, I'm not recalculating anything. I've only done calculations on the first one. And if you memorize quadrant 1, because you're a memorizer, you can figure out all the rest of them. The hardest part is going to be getting your degrees into radians.
That's gonna be hard without my
Not
calculator.
Oh, we don't have the calculator. Wait, no, are you serious?
Exactly.
I wasn't even gonna memorize it. I was gonna use my calculator. Wait, for what? Wait.
To divide by 180.
Nothing gives you the radians. What if?
Good.
What if I leave the radians unsimplified?
No, it's going to be simplified. Okay.
Like, we don't know that. I don't know.
All right. How about this? Look, don't miss this point. This is very important. This is 180 degrees, which is pi radians.
Wait, was it just pi?
It's just pi. It's just pi. 360 is 2 pi's. The tangent value here. No, 0. Negative 0, no. It's just 0. Undefined is at the top and the bottom. Side to side is 0. So how about now? All right, look at the homework sheet that you have. Does everybody have one now? The one that says station number 2, work in the unit circle. These, once you have your unit circle in front of you, you're just using your unit circle. All right. Oh, these are quick. You just find them. All right, so for instance, and here's what you're going to have to do. Here's the hardest part of these is finding the coterminal angles. Remember we talked about coterminal where you add 2 pi or add 180 or backwards or whatever. So if you get a radian value that's negative, you can either go in the negative direction, but what I do is just add 2 pi to it. And it's going to be a place on, for instance, you've got sine of negative 5 pi over 6. I'm going to do, instead of going from here and going negative 5 pi over 6, because I don't know where that lands, I'm going to say negative 5 pi over 6 plus 2 pi. Where does that land me? Remember common denominators. So I'd have negative 5 pi over 6 plus 12 pi over 6. 7 pi over 6. So I would go on my unit circle.
It's on the bottom. It's in the bottom left.
Right, it is. It's in the bottom left corner.
I know that makes sense.
You know.
I'm so genuinely
7 pi over 6 is actually your very next click here. And so the sign of 7 pi over 6, the coordinates here, so this one goes with the green, right? The degrees here would be 210.
So we're putting everything we're missing?
Yes, you're going to finish the other half of the unit circle. 7 pi over 6.
I'm talking about how are we answering these?
I'm fixing to show you. Let me put the coordinates here. This is negative square root of 3 over 2, negative 1/2. So once I have my unit circle filled, right, I found the coterminal angle that's actually on my unit circle. I go to 7 pi over 6. It's asking for sine. Sine is y, so this equals negative 1/2.
Oh.
Number 2, we haven't finished filling this out. Let's see. Yes, because it's the sign right there. All right, you see what I'm saying? It's easy. It's easy, right?
What if it wants tangent?
Yeah, so this one, the tangent here was negative square root of 3 over 3. The tangent here would just be square root of 3 over 3. Remember that little, in that bottom, the tangents are all positive. Yeah, we keep using, I'm trying to color code it so you see what goes with what here.
Y'all, I'm watching that. I can't wait. I'm so sorry. I have to write my whole
Oh, God.
There you go.